Hello, let's continue our Sudoku adventure with Mailer Demon by Gene. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these big arrows in the grid with a number inside. The number in the arrow is a sum, and it's the sum of the first n digits pointed to by the arrow, where n is the digit right behind the arrow. So for example, if this was a 3, this is the digit behind the arrow, so that's our count, that's n. So we take this, this, and this, these 3 cells, because that's a 3, and those would add to 9. So for example, 1, 2, 6. So this would be a valid filling for this 9. If instead this was a 2, we could make this 4, 5. It's because we now use 2 cells to add to 9, and these 2 do add to 9. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so we can kind of seed the links here, right? So we can do 7 and 2 very easily. There's lots of ways to do it. 7 and 3 is actually possible because we don't need to use the 3. We would be 3 with like 1, 2, 4 or something. So 2 or 3 there. To get to 9, we could do it in 2 or 3, but a 4 actually is minimum 11. Because we can't do 10, because 1, 2, 3, 4 would be 10, but we'd need to use the 4 as the count, which isn't part of the sum. All right, anyway, but 9 is possible, 2 or 3. 12, we can't do 12 and 2. That would be 6, 6. We're going to do 3 or 4 for 12. Now, can we do 12 without the 4? I think it would be 1, 2, 3, 6. Yeah, that would work. 1, 2, 3, 6 would work. 6, we can't actually do 6 and 3 because it would have to be 1, 2, 3, and the 3 is already gone. So the only way to do 6 is in 2. So that 2 is given. Oh no, we could do 1 or 2, sorry. Because this could just be a 6. I almost missed that case. 11, we just said we could do it in 4, so 3 or 4. Or 2. 5 plus 6 is 11. And then 12 we can't do in 2, but we could do in 3 or 4. We already talked about that. But this is a 1 or a 2. Does that make it hard to do 12 and 3? No, because we could do like 5, 6, 1, and that's perfectly fine. All right, so we can do it in 3 with the 1, 2. All right, so there must be more restrictions here. Oh, well, first of all, this can't be a 4 because there aren't 4 cells there. So we could do stuff like that. This could have 4. So, but this is a 2, 3, right? So if this was 4, how are we getting to 12 in 4 cells? Well, we'd actually be able to calculate what the outie is, right? Because we know these sum to 12. And this is a 4. So in total, these would sum to 16. And so if we want these to sum to 16, and the entire column sums to 21, because 1 through 6 sums to 21. 21 minus 16 is 5. This would have to be a 5. So this can't actually be a 4. It must be a 3. And now that's a 2. And now that's a 2. So these two sum to 9. 9 and 2 is 3, 6, or 4, 5. 3 is gone, so this is 4, 5. 7 and 2 without the 2 is either 1, 6. It's not 2, 5, or it's 3, 4. And that's not 3, so that's not 4. All right. 6 and 1 are 2. 12 and 3 without 2 or 3. So we actually know the outie, right? These sum to 12. These sum to 5. So 12 plus 5 is 17. To get from 17 to 21, we need to add 4. So this is the 4. That makes that 3. This is flowing very nicely. That's not a 3. So this has to be a 1, 6 pair to add to 7. These digits are 1, 5, 6. This 1, 6 has to end up down here somewhere. So this is our 1, 6. These are from 3, 4, 5, definitely. And this is the other 4, 5. So down here we need the 1, 6. Okay. These 3 sum to 12. So what are our outies? Let's think about that first. 15. So our outies add to 6. These 2 add to 6. So we're not going to use the 6 to do that. So this has to be actually 1, 5. 6 plus, I'm just double checking. 6 plus 15 is 21. Yeah, okay. Because that's huge. All right, so that's 4, that's 6, that's 5, that's 1. We got the 6 here. This is a 2. So these 2 add to 6. That's definitely not a 6. In fact, whenever you have only 2, so we know these 2 add to 6. A nice little shorthand is this cell has been limited to 1, 5. 1 plus 5 is 6. So this has to be the other 1, 5, right? So this is just going to duplicate there. which makes this a 6 because this is 1 5 pair. So these add to 12, which means these add to 6, which they do. We already kind of worked that out. 12 and 2 are 3. Do you think about the outies yet? I think there's probably Sudoku to do. We need a 4 6 here. Yeah, so this is 4, this is 6. Okay, so we already have 6. So it could be 2 with a 5 here. Otherwise, these both add to 5, but not 2 3. So it'd have to be 1 4. 1 4 seems okay. In fact, we know there's a 4 up here. So this is 4 or 5. No. 1 4 or 5. Sorry. Because it's either a 1 4 pair here or this is a 5. Hang on, whether this is 2 or 3. All right, we do know that the 3 is in one of these two. There must be more Sudoku to do. Ah, yeah, 6 is placed here. The 2 is in one of these two. In fact, this is just a triple. So we know the 2 is here. What else do we need? We need a 3 and a 4. Well, these both can't be 4. So the 4 is placed. That places the 3 here. That gives us 4 and 3 here. That places the 4 here. That makes this 3 and 1 for the sum. That's 5 and 1 and 5. That works. That's 2 and 3. This digit's a 2. Down here, we need the 1 and the 6. So that's 6 and that's 1. Down here, we need 2 and 5. That's 5 and 2. And then up here, we need the 1 and 5. That's 5 and 1. All right. Cool puzzle, Gene. I actually really enjoyed that. Had some interesting logic. I really liked being able to use the outies in this column. And then the outies again in this column in a little bit more complicated way. I always like when puzzles kind of teach you different things to look at. Cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.